Hi everyone, let's take a look at the following. Solve for x. Log of base 7 of x plus log of x of 7 equals to 5 divided by 2. Step 1. We write this as log x divided by log of 7 with a common base of 7. Likewise, if you look at the second term, we write log of 7 divided by log of x with the base of 7. Copy the right-hand side. Again, if you go back and you think about this, we know that log of 7 equals to 1. Likewise, log 7 of 7 equals to 1. In order to have no fractions, you have to multiply the left-hand side and the right-hand side by the common denominator. And in this case, if you think about it, the common denominator is going to be 2 times log of base 7 of x. So now what happens is on the left-hand side, this is going to be 2 times log of base 7 of x to the power of 2 plus 2, which equals to 5 times log of base 7 of x. Bring everything to the left-hand side. So you can copy 2 times log of base of 7 of x to the power of 2 minus 5 times log of base 7 of x plus 2 equal to 0. Again, if you're not comfortable factoring this as is, you can let a equal to log of base 7 of x. This means 2 times a squared minus 5 times a plus 2 equals to 0. This is complex factoring, something you did back in grade 10 math. 2a squared becomes 2a and a, the factors of 2. That will give you a sum of negative 5 is going to be negative 1, negative 2, just like that. You go back and you recognize the fact that a equals to log base 7 of x means 2 times log of base 7 of x minus 1 equals to 0. This means if you isolate for log of base 7 of x, that's going to be half. By definition, if you go from logarithmic to exponential, x equals to 7 to the power of half, or 7 under a square root. So x equals to the square root of 7. In the second column, same idea. Log of base of 7 of x minus 2 equals to 0. Log of base 7 of x equals to 2. Again, x equals to 7 squared. X equals to 49. Now, normally we stop here, but you really want to go back and double check your work. So in a different color, I'm going to show you how that works. Double checking just means you take the calculator and you plug it back in. So it's not a formal double checking. You're just double checking with the calculator. So on the left hand side, if you think about this, you can plug in root 7 back in the original function. So this is going to be log of base 7 of root 7 plus log of root 7 of 7. And again, if you look at this, the first term is going to be half, and the second term is going to be 2, which will give you exactly 2.5, which is the same as the right-hand side. Likewise, if we check the second case, the left-hand side equals to log of base 7 of 49 plus log of 49 of 7. And again, this is going to give you 2 plus half, which is 2.5, which equals to the right-hand side. I hope this makes sense.